Good afternoon, 8th and ninth grade. Today we are again looking at science lesson 375. It actually starts on 374 at the bottom, but 375 to 382. And again, I have two sets of on your own problems, but they're pretty easy. I found today's lesson to be quite simple until you start talking about reflection and refraction, which way they go. And until you get to the question, you say, if you see the fish in the water and you want to spear him, should you spear in front of him or right at him or behind him? Because of the refraction that the speed of light travels. So let me talk about that just a little bit in connection from the other lesson. We understood, or we talked about, I hope you understood, that light travels the fastest in air or vacuum in a gas. And then it travels slower in a liquid. And then of course the slowest of all in a solid. Just different or backwards from sound. Sound can't travel in a vacuum, but it travels the slowest in air, faster in a liquid, and faster yet in a solid. So light and sound are different in the way they travel. So today we talk about, the first title is reflection. This is nothing new to you. You know that light reflects. And that's the reason that I had to turn out these other lights here and use side lights to shine in here because they were reflecting on the board. Pretty simple. Let me talk about how light reflects. Light, you have an example there on 15.2. So be sure to do that example. You can look at the pictures and you can kind of see, but it's not quite like doing the real thing, you know? If you do the real thing, it sticks a little better. So do that, and be sure to wear those eye protective such as goggles or safety glasses. That's the first thing to do. I kind of laugh at his. I guess you should wear sunglasses if you're working with light. They might damage your eye. But let me talk about after you've done the experiment, go to 376, and this is what you learned in the experiment. The experiment is. And you know how this is. This here, the light shines down this way. I put an arrow on here. And then let's say this blue thing is a mirror. It might be the chalkboard. It could be something shiny. And I've seen this happen already in my teaching experience, that there was someone sitting by the window and the sun was shining in the window onto their desk or onto their something that they would hold, and then they could make it shine over and hit another student. Have you ever seen that happen? Even like a watch. If you got a watch and the sun could hit the surface of that watch and it would work like a mirror and it would shine over. Well, in your experiment, you learned that the angle that this here hit, whatever angle the sun hits, the reflection is going to be the same angle from a perpendicular line. Now, I'm not sure, and looking in your picture, it looks like my angles aren't the same. This guy here should maybe be brought down just a little bit to make him the same. If the arrow hits there, maybe he should go like this. But this is equal. This angle from here to here, here to here is the same. That's equal angle. That's just, this here is called the angle of incidence, and then the angle of reflection. Incidence and reflection are your two words on 376 that are bold. And that is just simply condensed down to the word that you need to know, the definition. This is called the law of reflection. The angle of reflection equals the angle of incidence. So think of it in this way. Inciding, it'd be like coming down and going out, reflecting. This angle from here to here is identical to here to here. The angle's same. And if you do the experiment, you can figure that out. At the bottom, you see, on 376, you see the person looking in the mirror. That is so funny. You can sit here, if the mirror is, let's say, over on that wall, I can sit here and I can have a wall right here in front of me. Okay, I can't see, but I can look over at the mirror, and if that wall doesn't go all the way to the mirror, and then from the mirror, it'll shine back over to there. And I can see behind the mirror. So you can put a wall right here in front of me, but if you put a mirror over there, and I stand at the correct angle, I can see you on the other side of the wall. Okay, that is just another illustration of how the law of reflection, the incidence and the reflection. Yeah, you got the picture of the lady looking in the mirror, and she can see her foot. Ain't that amazing? It looks to me like someone should use a boat clippers, or ain't that the way they say you clip those heels off a little bit and drop her down a couple notches. Well, that's beside the point. When you look at the flashlight on today's lesson, you'll need to draw the angle with the flashlight. When it hits the mirror, it's going to refract the other way. So be sure to make the complete. I'm going to tell you any more answers. Now, I am going on over to the bottom of 377. Today, the first lesson is reflection. Okay? So reflection, angle of incidence, the angle of reflection equals the law of reflection. Now today is a word that's almost the same, except it's called refraction. The next section is refraction. Now this here can get you confused, okay? So you have to be a little careful here. This here law is pretty simple. The angle you shine on tilts it back. When the light shines in the window and you use a little mirror to shine over to your classmate and to shine in their eyes, you can make the sun shining on your desk reflect over in his eyes and distract him and make your teacher upset. You know how that works. You've been there. You've done it. I mean, I don't know, you got your teacher upset. Yeah, let's skip that part. Refraction. It happens when the waves are refracted. So now you need to perform the experiment on page 378 and 379. And again, this is not a hard experiment. It doesn't take a lot of brains. It takes a little time. And be sure to do number 12 again. May I stress that. You need to do number 12 at the end. Clean up your mess. Okay. When this happens, when light, now remember, we're going back to this principle that you learned the other day, that light travels faster in air than in a liquid. And of course, the slowest of all in a solid. So, when it comes flying in, and then it slows down when it hits the water. And you need to do that experiment. Put a little milk in your bowl and, do that experiment. I'll just let that there go. It says, the fact that light rays bend when they are refracted is a general rule of physics. Okay, it's just a law. We have the law of this and the law of that. Well, a law is when light hits water, it refracts and bends like this. Look at your black sayings. When light refracts in a substance in which, I'm on bottom of 379. When light refracts in a substance in which it must slow down, the light rays will bend toward a line perpendicular to the surface it strikes. Okay? So if you got a perpendicular line, it hits this surface, it bends toward. Okay? And we'll experiment that or show you that just in a minute. And then it says, when light refracts in a substance in which it speeds up, the light will bend away from a line perpendicular to the surface it strikes. Okay? Now turn the page, and we will see how that works. You are on page 380 now, and at the top, and I will show you a video of this here, or a little clip of this here, in another video, or I might do it on this video, I'm not sure, but I will show you how this works. Refracted and reflected, it gives you the two examples. Refracted just bends it, and reflected sends it back the other way. And I need to talk about one more thing yet, or a couple more things, is you've heard of a mirage. I talked about a mirage, I think here in school maybe even. And it is whenever you look out ahead and you say, oh, I see water up there on the road, or I see water on the surface. And when you get there, there's nothing there. It's as dry as a bone. Well, what happens is there's heat waves that come out of the ground, and then when the sun shines on these heat waves, it reflects the sky up above. And so the reason it looks like it's water, well, the sky is blue, or the sky is kind of light colored, and so on that little surface, oh, there's some water up ahead. It's a mirage. It's called a mirage, and that it's an illusion, an optical illusion, we say, which we'll talk more about optical here in tomorrow's lesson or the next lesson. But it's a fooling. Or it's a reflection. That's what it is, and it's not true. It looks like water, but it's actually just reflecting the sky down onto the ground. Again, you need to do this experiment, and the experiment is like the picture on over here. The 15.4 experiment is the same as what happens there. So get your old bowl with water, put a quarter in it. And you got to have dark side so you can't see it. Put your quarter in the bowl and then slide the bowl away from you and then go and pour water into the bowl, and all of a sudden you'll be able to see the quarter again. It's because of the refraction of light. It's a mystical thing, he says. A magical quarter. There we go. I missed it. Magical. You need to do this experiment. There we go. You must do this experiment. You have no excuse. You cannot get out of doing this one. And then you turn over to 382 and do the top of that page. So let me talk about that just a little bit. The fish is in the water. The first question. No, it'd be the second question. And if any of you have ever been spearing fish, this is going to be a duh question. You know this. But if you're out in a boat or standing on the bank, probably on a boat, and the water is really clear, and you can see the fish, and you want to spear them. It's got the refraction, okay? So if you either go back, look at the picture on page 380 on 15.6, that figure 15.6, which I'm going to show you a video of that here just in a minute. But look where the fish is. Look where your light shines. And the fish, if you look at it, it fools you. And so in reality, if I'm on the first question, in reality, when you see the fish, you look in like it's here, but the light has refracted, and so it's like it's here. And while the fish looks like it's right there, it's right here. Okay? Okay, you got it? The fish looks like he's right there, but really he's right here, because the light refracts. Does that help you with number one? I'll tell you the answer then later. Yeah, I think I'm ready to show you that video. Just hang on here a second. I hope you can see it.
In this situation, we have a light source shining a beam of light onto a container of water. Now what's going to happen is that beam of light travels to the container of water and hits
If I can hold it still, it would help you not.
When light hits a surface, there's a possibility for both reflection and refraction.
Okay.
Let's start with reflection. According to the law of reflection, a line perpendicular to the surface at the point of contact is very important. So let's draw that line now. So that dashed line is perpendicular to the surface at the point where the light beam hits the surface. Now, according to the law of reflection, a reflected ray will come off with an angle relative to that line that is equal to the original angle. So let's draw that in now. You see how the reflected ray has the same basic angle away from that dashed line as the incident ray does. So that's the reflected ray that will come off the surface. But that's not the only thing that can happen, right? The light can also travel into the water. But because light travels more slowly in water than air, refraction tells us that the light will bend towards that perpendicular line. So the light that enters the water will be closer to that dashed line than the light that came from the flashlight. That's what we call the refracted ray. Now the refracted ray will travel through the water, and nothing will happen to it until it hits the other side of the container. At that point, the same two things can happen. So some of the light will be reflected. We'll draw our perpendicular again, and we know that the reflected ray has the same angle relative to that perpendicular as the ray that hit that side of the container. However, some of that light will also refract out of the container. But think about what happens when the light leaves the container. It will now be traveling in air. Light travels more quickly in air than it does in water, so according to what you learned about refraction, that means the light will be bent away from the perpendicular. So the final refracted ray will be farther away from the dashed line than the ray that's inside the container.
Okay, I hope that gives you a little bit, gives you a better clue. I will see you next week or next day.